You're looking to really get a handle on something important and fast, right?
Yeah, cut through the noise.
Exactly. And understand what actually matters. That's why you're here. Welcome to the deep dive. We dig into the crucial stuff so you don't have to.
And today, we're looking at a pretty fundamental shift potentially happening in artificial intelligence.
Absolutely. You shared this preprint, really fascinating stuff from David Silver and Richard Sutton, big names in AI.
That's right, leading researchers.
They're talking about this new era of experience for AI. So it's not just about feeding it tons of human data anymore.
Precisely. They argue that's reaching its limits. The next big step, they believe, is AI learning by interacting with the world itself.
Okay, so the paper makes this case that the current approach, the era of human data, large language models, all that.
Yeah.
It's been amazing, but maybe hitting a ceiling.
That's the core argument. Impressive progress, yes, but limitations are showing up. So our mission for this deep dive is to unpack what this era of experience actually means.
Right. Why do they think it's next? And, crucially, what could it mean for AI's abilities and, well, for us? For you listening.
Yeah, the real-world implications.
Okay, so let's quickly set the scene. The era of human data. We've all seen LLMs doing incredible things, writing code, answering complex questions.
For sure. I mean, they train on these enormous data sets of human text, human code, and they get surprisingly good at generalizing, doing lots of different tasks, summarizing, creating stuff.
But the paper says that approach, which is basically learning by imitation, it can only get AI so far.
That's a key point they make, especially when you talk about pushing the real boundaries, things like advanced math or fundamental science.
Stuff where we want genuinely new insights, not just rehashing what humans already figured out.
Exactly. The argument is that truly novel breakthroughs, the kind that shift paradigms, well, they probably lie outside our current understanding.
Which means they're not in the human data we're feeding the AI now.
Right. It can only learn what's already there, essentially.
And they also mentioned that progress seems to be slowing down a bit with this supervised learning approach.
That's another indicator they point to. It suggests the really valuable human data, the low-hanging fruit maybe, is getting harder to find or leverage for big performance jumps.
Okay, so if we're hitting limitations with human data, what's next? That brings us to the era of experience. AI generating its own data.
That's the idea. Instead of just learning from static data sets we create, these AI agents learn continuously from their own actions and observations, from the data they generate themselves by doing things in their environment.
So it's dynamic, ongoing learning, not capped by what we already know.
Precisely. It allows for continuous improvement theoretically beyond human limits.
They used that AlphaProof example, the AI that got an IMO medal. That wasn't just learning from human proofs, was it?
No, and that's what's so interesting. It started with maybe 100,000 human-written formal proofs. A decent amount, but not huge by today's standards. But then, using reinforcement learning, think of it like trial and error with rewards, it generated 100 million more proofs itself.
Wow.
By interacting with a proof-checking system, getting rewarded for making valid steps, it basically practiced massively and found solutions humans hadn't.
So the key insight there for listeners is that by practicing on its own, it could actually surpass the human examples it started with.
Exactly. It discovered new ways. And they mentioned DeepSeek, too, another case where reinforcement learning helped AI develop advanced problem-solving skills pretty much on its own.
Right. So these examples really show the potential of learning from experience.
They do. And the authors say this new era will have some key characteristics, things that make it different from the AI we mostly see today.
Okay, let's get into those. First up, streams of experience.
Yeah.
It sounds like longer interactions, not just question-answer.
Yeah, a big shift. Think about how you use, say, a chatbot now. You ask something, get an answer, maybe ask a follow-up, but it's usually short episodes.
Right, there's no real memory or continuity usually.
Exactly. Experiential agents, though, would operate in these continuous lifelong streams of actions and observations, more like how we learn over time.
Adapting constantly, pursuing long-term goals.
Uh-huh. The paper gives examples like a health agent monitoring you for years, or an education tutor tracking your progress long-term.
Or even science agents working on big, slow research projects like finding new materials. That takes time.
It does. And the point is, the AI makes actions that might not pay off immediately, but contribute to a goal way down the line. It's thinking longer term, based on its continuous interaction.
So the takeaway is future AI might be more like a persistent partner learning alongside you.
That's the potential, yeah. A dedicated assistant that evolves.
Okay, second characteristic, grounded actions and observations. This means getting beyond just text, right? AI actually doing things.
Precisely. Moving beyond just processing language, these agents would interact with the world, digital and physical, using sensors, motor controls, APIs, maybe even the same UIs we use.
So actually interacting with the environment, not just reading about it.
Yeah, think of an AI physically manipulating things in a lab or navigating a complex software system autonomously. It's about active engagement and learning from that direct feedback.
So it can explore, adapt to what it sees, maybe find strategies we wouldn't think of because it's learning from the raw interaction.
Exactly. That scientific agent controlling a robot arm is a great image for this.
So the insight here is AI won't just talk, it'll do. Learning by doing could lead to totally new solutions.
And it can act in the digital world, too, using the same tools we do. Managing complex systems, maybe.
Okay, third one, grounded rewards. This sounds important. Moving away from humans deciding if the AI did well.
Yes, this is potentially huge. Right now, often a human expert looks at what an AI did and says, good or bad. That's the reward signal.
But that limits the AI to what the human thinks is good.
Exactly. It creates a ceiling based on human judgment. Grounded rewards come directly from the environment. Did the action achieve the real-world goal?
Like, did your health metrics actually improve? Did the student actually pass the exam? Did the CO2 level actually drop?
Precisely. The outcome itself is the reward signal. And they point out human feedback can also be a grounded reward, like, did the recipe taste good? How tired do you feel after the workout?
Ah, okay. So it's about measuring the real consequence, not just someone's opinion.
Right. And the idea is learning from these real outcomes could let AI surpass human performance because it's not limited by our preconceptions of the right way.
And there must be tons of potential grounded signals out there. Efficiency, cost, error rates.
A huge amount. Anything measurable in the environment could potentially be a reward signal. They even suggest optimizing for one good grounded reward might be enough to drive general intelligence in some complex settings.
How do you guide it, though? If it's just optimizing for, say, efficiency, could it go wrong?
That's a crucial point they address. They talk about adapting the reward based on user goals, maybe through something complex like bi-level optimization. So the user still sets the overall direction and values, even if the AI learns from environmental signals day to day.
Okay, that makes sense. Keep the human in the loop on the big picture. Fourth characteristic, planning and reasoning beyond human terms, suggesting AI might think differently.
Exactly. A lot of current AI reasoning tries to mimic how humans think, maybe using language-like steps, chain of thought.
Yeah, we see that.
But the authors argue, look, human language evolved for communication between us. It's probably not the most efficient way for an AI to compute or reason internally.
So learning from experience, from consequences, might let AI discover totally different, maybe more effective ways of thinking.
That's the hypothesis. We see hints with AlphaProof, again, solving math problems in ways humans found novel, even alien.
And grounding that reasoning in real-world data helps avoid flawed human assumptions baked into the training data.
Absolutely critical, like how science progresses by testing ideas against reality. Experiential AI has that built-in feedback loop.
They mention world models here, too, like an internal simulation.
Yeah, basically the AI learns to predict what will happen if it takes certain actions. It builds a model of how the world works based on its experience.
And that lets it plan, figure out cause and effect.
Precisely. If I do X, the world model predicts Y will happen. That's essential for effective planning towards a goal.
So the insight, AI might not think like us, but grounded in reality, its reasoning could be more powerful.
Potentially, yes. It's reasoning based on predicting consequences.
Okay, so that's the picture of the era of experience. Why now? You mentioned reinforcement learning coming back.
Yeah, RL is key here. It's got a long history, remember? AI playing games, Atari, Go, chess. That was often RL in simulated worlds.
Right, the era of simulation, they call it.
But then the focus shifted heavily to the era of human data, the big language models, because they showed such broad abilities quickly.
But we lost something.
The authors argue we lost that power of self-discovery, like how AlphaZero found chess strategies humans hadn't seen. Learning purely from human data doesn't really allow for that kind of leap.
So the era of experience tries to bring back that self-discovery, but combine it with the broad applicability we see now.
Exactly. By having agents interact autonomously in the real world, learning from grounded rewards, you get both generality and discovery.
And the tech is getting there. Better autonomous agents, better RL algorithms for open-ended stuff.
That's the argument. The pieces are falling into place. They mention revisiting and improving core RL concepts, temporal difference learning, exploration, world models, planning over time. The foundations are being strengthened for this new phase.
Okay. It sounds incredibly powerful. What are the consequences? The good and the bad?
Well, the potential upside is huge. Imagine truly personalized long-term assistants that really understand you.
Like that health agent or education tutor we talked about.
Right. And accelerating science, new materials, new medicines, discovering things at a rate we can barely imagine now. That's a massive potential positive.
But the flip side, there are always concerns. Job displacement, AI doing things we thought only humans could do, like real innovation.
Definitely things to consider. And the risks may be increased with more autonomous agents operating over long timescales. We need robust safety and reliability.
And if they start thinking in non-human ways, can we even understand what they're doing or why?
That's another challenge. Interpretability might become harder.
But they also mentioned potential safety benefits from this approach. That seems counterintuitive.
Yeah, it's interesting. Because they learn from the real world, they might be better at adapting if the environment changes unexpectedly. A fixed system might fail, but an experiential one could adjust.
Okay, I see.
And crucially, the reward function itself can be adjusted based on feedback. If the AI starts doing something concerning, we could potentially tweak its goals based on, say, human feedback acting as a grounded signal.
So it might be less prone to rigidly following a flawed objective,
Yeah.
like the classic paperclip maximizer thought experiment.
Potentially, yes. The ability to adapt the reward provides a possible safety mechanism that fixed systems lack.
But there's a natural break, too, isn't there? Learning from the real physical world takes time.
That's a really important point they make. Actions take time, observations take time. Physics is slow compared to computation. So at least for agents interacting physically, that might prevent runaway self-improvement, a natural constraint.
Right. Things don't happen instantly in the real world.
Exactly.
Okay, so wrapping this up for everyone listening, the big takeaway seems to be AI is likely moving beyond just learning from our data.
Yeah, it's shifting towards learning by doing, engaging directly with the world.
And that could unlock capabilities well beyond what we see now, maybe even superhuman in some areas, changing, well, pretty much everything.
That's the potential. This experiential data, the stuff AI generates itself, could become far more important than the human data we've relied on, driving a new kind of AI.
One based on autonomous learning and discovery.
Right, learning through direct experience.
Which leaves us with a pretty big question, doesn't it?
Okay.
As AI learns more from its own experiences, maybe develops these non-human ways of understanding, how does our relationship with it change? What new possibilities open up? And what challenges might we not even foresee yet from this really different kind of intelligence? Something to think about, definitely, whatever you work on.
Absolutely.
This deep dive is really just scratching the surface, of course. We definitely encourage you to look more into this shift. It feels pivotal. Thanks for joining us.